SOT small outline transistor 23. SOT23 is a 3-terminal diode or commonly used for low power signal diodes, small signal rectifiers and voltage clamping diodes. It is used in various electronic circuits including consumer electronics, telecommunications and automotive applications. The SOT89 package typically has 4 leads: base, emitter and collector. This package is designed for surface mounting onto a PCB. SMD diodes in the SOT89 package are often used in voltage regulation circuits, rectification in AC to DC converters. SOT143. SMD components in SOT143 packages can include small signal transistors, diodes, voltage regulators and more. It is commonly used in a variety of electronic devices and circuits including amplifiers, oscillators, voltage regulators and more. BAV99. The BAV99 diode contains 2 diodes connected in series within the same package. This allows for more efficient use of space in compact electronic designs. It is usually housed in a SOT23 package which has 3 terminals arranged in a specific configuration. Let us discuss SMD LEDs in the SOT23 package. Surface mounted device LED chips are the next major development after dual inline packages. Compared with traditional LEDs, the light output generated by SMD is much higher and consumes less power. Compared with DAP LEDs, they have a smaller, flatter design, a longer surface life, reduced energy consumption by up to 75% and lower maintenance cost. These are basic LEDs available in various colors such as red, green, blue, yellow and white. They come in different package size like 3528, 3014, 5050, 5630, 3030, 2835, 3535. SMD LEDs comes in various package sizes and configuration, each with its own characteristics and applications. SMD LEDs in SOT23 packages are available in various colors including white, red, green, yellow and blue. The SOT23 package typically has 3 leads: one anode positive terminal, one cathode negative terminal and one additional lead for other purposes such as connecting to a heat sink or providing a ground connection. Plastic leaded chip carrier LEDs. PLCC LEDs are larger than standard SMD LEDs and typically come in packages with 4 or more leads. They are commonly used in applications where higher brightness or special features such as RGB, red, green and blue color mixing are required. SMD LEDs have markings on their body indicating the polarity. Look for a small indicator such as a line or a dot near one of the terminals. This terminal is typically the cathode negative while the other terminal is the anode positive. Let us discuss SMD transistors. 3-terminal SMD transistors are electronic components with 3 terminals used for amplifying or switching electronic signals. Surface mount device transistor comes in various package types, each designed for specific applications and manufacturing requirements. SOT23. This is one of the most popular SMD transistor packages. It is small and typically has 3 leads. The leads are usually bent to form a triangular shape with one lead for the collector, one for the base and one for the emitter. SOT23 packages are widely used for general purpose transistors. SOT89. This package is slightly larger than the SOT23 and can accommodate transistors with higher power ratings. It has 4 leads and is commonly used for voltage regulators and power transistors. SOT223. SOT223 package is used for medium power transistors and voltage regulators. It has 4 leads providing additional thermal and electrical connections compared to the SOT89. To identify whether the SMD transistor is PNP or NPN and the terminals emitter, collector and base, the most reliable way to determine the type of SMD transistor is to refer to its datasheet. The datasheet typically provides detailed information about the part, including its pinout, electrical characteristics, and sometimes even the orientation of the part. Let us look into SMD FET and MOSFET device. SOT23. This is one of the most common and versatile SMD packages used for small signal transistors, including FETs and MOSFETs. It typically has 3 leads and is suitable for low power applications. SOT223, SMD FETs and MOSFETs are also available in the SOT223 package, which has 4 leads and provides better thermal dissipation compared to SOT23. This package is suitable for medium power applications. Drain, source and gate terminals in SMD, FETs and MOSFETs can be identified by the data sheet provided by the manufacturer. Let us look into different types of packages in SMD integrated circuits. SO, small outline, 8 pins to 16 pins. SOJ, small outline J lead, 16 pins to 40 pins. VSOP, very small outline package, 32 pins to 56 pins. SSOP, shrink small outline package, 8 pins to 30 pins. QSOP, quarter small outline package, 20 pins to 56 pins. QFP, quad flat pack, 32 pins to 304 pins. PQFP, plastic quad flat pack, more than 100 pins. CQFP, ceramic multi-layer QFP, 32 pins to 304 pins. BQFP, pumpered quad flat pack, 84 pins to 196 pins. LQFP, low quad flat pack, up to 208 pins. TSOP, thin small outline package, 8 pins to 64 pins. BGA, ball grid array.
In this video, we have discussed how to identify 2, 3 and 4 terminal devices such as diodes, transistors, MOSFETs and different packages in integrated circuits. This concludes the exercise. Thank you for watching. Hello everyone. In today's video, let us learn how to demonstrate the components and sections of LCD, LED and Smart TV. For ease of understanding, the video is split into 2 parts. Part 1 covers Objective 1 and 2 and rest is covered in Part 2.
At the end of this video, you will be able to dismantle the back panel cover of the LCD TV, identify the internal sections in LCD TV, dismantle the back panel cover of the LED TV, identify the internal sections in LED TV. Let us collect the tools and equipment required to do this practical. Trainees Toolkit, LCD TV with user manual, LED TV with user manual. Remove the back panel cover of the LCD TV and identify the sections. Unplug the LCD TV from its power supply and remove any other cables from the TV. Identify the power cable connected to the back or side of the TV. Gently grasp the plug of the power cable where it connects to the TV. Identify the signal cables connected to the TV. These may include HDMI cables or coaxial cables depending on the setup. Gently grasp the connector where it plugs into the TV's input port. Repeat this process for each one until all signal cables are disconnected. Choose a clean and spacious area to work, preferably a flat surface like a table or floor covered with a soft cloth or blanket. Ensure that there is sufficient space to safely move the TV. Carefully lift the TV from its base or stand and gently lay it face down on the soft cloth. Take care not to apply excessive pressure on the screen, as this could cause damage. Depending on the type of screws used, select the appropriate screwdriver or tool. It is essential to use the correct size and type of screwdriver to avoid stripping the screws. Insert the screwdriver into the head of one of the screws and turn it counterclockwise to loosen it. Repeat this process for each of the 4 screws, gradually loosening them until they are fully unscrewed from the TV. Remove the outer cover to show the main body of the TV monitor. With the screws removed, the base should now be detached from the TV. Gently lift the base away from the TV and set it aside in a safe location. Identify the different sections in LCD TV. Main board or motherboard. Look for the largest circuit board inside the TV. This is usually the motherboard or main board. The main board is the central hub of the TV containing the processor, memory, input and output ports and other essential components. Microprocessor. Microprocessors are responsible for decoding and processing incoming video signals from various sources such as cable, satellite or streaming devices. RAM, random access memory, stores temporary data and program instructions for the CPU to access quickly. Input and output ports, allows external devices to connect to the TV including HDMI ports, USB ports, audio jacks, Ethernet ports and antenna connectors. Power supply board. The power supply board will have various components such as capacitors, transformers, diodes, regulators, etc. The power supply board in an LCD TV is a crucial component responsible for converting incoming AC power from the wall outlet into the DC power needed to operate the TV's internal electronics. Input connector. The input connector is where the power cord from the wall outlet connects to the TV. Fuse. The fuse protects the TV from overcurrent conditions by breaking the circuit if the current exceeds a safe level. Transformers are used to step down or step up the voltage levels as needed by different components of the TV. Rectifier. The rectifier converts alternating current AC from the main supply into direct current DC that can be used by the TV's components. It typically consists of diodes arranged in a bridge configuration. Filter capacitors. Filter capacitors smooth out the DC output from the rectifier, reducing ripple and ensuring a stable voltage supply to the TV's components. Output connectors. The output connectors distribute the regulated DC power to the various components of the TV, including the mainboard, backlighting system, audio amplifier, and other peripheral devices. Inverter board for CCFL backlights. The primary function of the inverter board is to convert the low voltage DC power from the power supply board into the high voltage AC power required to illuminate evenly across the LCD panel. The high voltage transformer steps up the voltage from the main power supply to the level required by the backlight. It also ensures that the AC power provided to the backlight is at the correct frequency and voltage for optimal performance. Inverter IC, LED backlighting. In modern LCD TVs with LED backlighting, an inverter integrated circuit IC is used to regulate the power supplied to the LED backlight. This IC controls the brightness of the LEDs by adjusting the current flow. MOSFETs, metal oxide semiconductor field effect transistors. MOSFETs are used as switches to control the current flowing through the backlighting system. They are turned on and off rapidly to modulate the brightness of the backlight LEDs or CCFL lamps. LCD panel, liquid crystal display panel. At the heart of the LCD panel is a layer of liquid crystal material sandwiched between two layers of glass or plastic substrates. The liquid crystal molecules in this layer can twist and change orientation when an electric field is applied, allowing precise control over the passage of light. T-con board, timing control board. The T-con board, also known as the timing controller or controller board, processes video signals received from the main board and controls the timing and pixel activation of the LCD panel. Timing controller IC, T-con IC. The heart of the T-con board, this integrated circuit generates timing signals to control the scanning of pixels on the LCD panel. LVDS, Low Voltage Differential Signaling Transmitter. LVDS transmitters convert the digital video signals from the T-con IC into LVDS signals, which are used to transmit data from the T-con board to the LCD panel. Audio board. The audio board processes audio signals received from external devices or internal sources such as TV tuners or streaming apps. Audio amplifier IC. The audio amplifier IC is the main component responsible for amplifying the audio signals received from the TV's mainboard or external audio sources. IR sensor and control buttons. The IR sensor receives signals from the TV remote control, allowing users to navigate menus, adjust settings, and control playback. IR receiver module. This is the main component that detects infrared signals from a remote control. It typically consists of a photodiode or phototransistor that converts received infrared light into an electrical signal. Control buttons located on the TV itself provide basic functionality such as power on, power off, volume control, and input selection without the need for a remote. Retrieve the back cover of the TV and align the back cover with the TV chassis, ensuring that all screw holes and connectors line up properly.
In this video, we have discussed how to dismantle the back panel cover of the LCD TV. Identify the internal sections of the LCD TV. This concludes part 1. See you in part 2. Hello everyone. In part 1, we learned how to dismantle the back panel cover of the LCD TV, identify the internal sections of the LCD TV. In continuation of that, here we discuss how to dismantle the back panel cover of the LED TV, identify the internal sections of an LED TV.
Let us discuss the difference between LCD and LED TVs. LCD TV. Traditional LCD TVs use CCFLs, cold cathode fluorescent lamps, as a backlight source. CCFLs are positioned behind the LCD panel and emit white fluorescent light, which passes through the liquid crystal layer to produce images on the screen. LED TV. LED TVs use LEDs, light-emitting diodes, as the backlight source. LEDs are positioned behind the LCD panel and emit either white or RGB, red, green, blue, light directly onto the LCD panel. LED TVs can be further classified into two types. Edge-lit LED TVs, where LEDs are placed around the edges of the panel, and direct-lit LED TVs, where LEDs are positioned directly behind the panel. LED TVs are more energy efficient than LCD TVs with CCFL backlights. LEDs consume less power, produce less heat, and offer better control over brightness levels, resulting in lower energy consumption and longer lifespan. LED TVs typically offer better color reproduction and higher color accuracy than LCD TVs with CCFL backlights. RGB LEDs can produce a wider range of colors and finer color gradations, resulting in more vibrant and lifelike images. Remove the back panel cover of the LED TV and identify the sections. Identify the power cable and signal cable connected to the LED TV. Gently grasp the plug of the power cable and signal cables from the TV until all the cables are disconnected. Carefully lift the TV from its base and gently lay it face down on the soft cloth. Take care not to apply excessive pressure on the screen, as this could cause damage. Insert the screwdriver into the head of one of the screws and turn it counterclockwise to loosen it by using the appropriate screwdriver. Repeat this process for each of the 4 screws, gradually loosening them until they are fully unscrewed from the TV. Remove the outer cover to show the main body of the TV monitor. Identify the different sections in LED TV. Motherboard. The main components of the motherboard of the LED TV consist of a microprocessor, RAM, random access memory, input and output ports, and control interfaces. Microprocessor. The central processing unit handles the TV's overall operation, including processing input signals, running the operating system, and executing commands. Random access memory stores data temporarily for quick access by the CPU. Input and output ports. These ports allow connections to external devices such as HDMI ports and audio ports for speakers or headphones. Scanner board. In LED TVs, the term scanner board typically refers to the T-con board, timing control board, also known as the timing controller. Timing controller T-con IC. This is the main integrated circuit on the scanner board responsible for interpreting the incoming video signal and generating timing signals to drive the pixels on the display panel. LVDS cable. LVDS stands for Low Voltage Differential Signaling, and it is a type of interface used in LED TVs and other displays to transmit high-speed digital video signals between the main board and the T-con timing control board. Power supply board. The power supply board in an LED TV is a critical component responsible for converting AC, alternating current, power from the mains electricity supply into the various DC, direct current voltages required to power the internal electronics of the TV. Rectifier diodes or bridge rectifier. These components convert the AC input voltage into DC voltage. Filter capacitors. Capacitors are used to smooth out the rectified DC voltage, reducing ripple and ensuring a steady supply of power to the TV's components. Voltage regulator ICs. These integrated circuits regulate the voltage to specific levels required by various parts of the TV. Inductors. They store energy in a magnetic field and help smooth out the output voltage. Resistors and capacitors. These passive components are used for various purposes such as voltage dividers, timing circuits, and noise filtering. Heat sink. Components such as voltage regulators or switching transistors may generate heat during operation. Let us discuss on backlight LEDs. Gently turn the LED TV facing upward to remove the top bezel. Inspect the top bezel to identify any screws or clips securing it to the TV chassis. These screws or clips may be located along the edges or corners of the bezel. If there are clips holding the top bezel in place, use a bezel opener to carefully remove them. Once the top bezel is partially removed, you may encounter cables connecting the bezel to the TV chassis. These cables may include the LVDS cable for the LCD panel, control buttons, or LED indicator lights. Take note of their positions and orientations for reassembly later. Carefully disconnect any cables or connectors by gently pulling them apart. With the screws and clips released and any cables disconnected, carefully lift the top bezel away from the TV chases. Be gentle to avoid damaging the bezel or the internal components of the TV. Reflector sheets in LED TVs are thin, reflective materials placed strategically behind the backlight LEDs to improve light efficiency and uniformity. With the top bezel removed, you can now access the internal components of the TV such as the LCD panel, LED backlighting. LED TVs may use different types of backlighting configurations including edge lit LED and direct lit LED. Direct lit LED TVs have LEDs positioned directly behind the LCD panel, providing more uniform illumination and better control over brightness levels. LED backlighting is more energy efficient compared to CCFL backlighting as LEDs consume less power and produce less heat. This contributes to lower energy consumption and longer lifespan for LED TVs. Now reassemble an LED TV as in the sequence of dismantled items. Place the top bezel on the TV module and secure it using the screw. Turn the LED TV facing the back cover on top and mount the cover, which was removed earlier with screws.
In this video, we have discussed how to dismantle the back panel cover of the LED TV, identify the internal sections of an LED TV. This concludes the exercise. Thank you for watching.
Hello everyone, in today's video, let us learn how to install a solar power panel 500 watt peak to directly 12 volt DC application.
At the end of this video, you will be able to install a solar power panel 500 watt peak for 12 volt DC application, construct an application circuit for 12 volt DC application. Let us collect the tools, equipment and materials required to do this practical. Digital multimeter with props, trainees toolkit, solar PV panel 12 volt 500 watt peak with fabricated panel support fittings, solar charge controller type PWM, system voltage 12 to 24 volt, maximum output current 50 amps, DC circuit breaker 2 pole 12 volt 6 amps, connecting wires 1.5 square mm and 6 square mm as required. DC fan 12 volt, base brackets 28 inches 6 numbers, contact brackets 28 inches 6 numbers, supporting brackets 14.8 inches, bolt and nuts 8 mm. Installing a solar power panel 500 WP for 12 volt DC application. Lifting the solar panels to the top of the terrace. Safety precautions. Lifting a solar panel to a terrace typically requires at least 2 or 3 strong individuals to do so safely. Treat solar panels delicately and avoid rough handling. They are made of tempered glass which can break if subjected to excessive force or pressure. Ensure that all the people who are lifting the solar panel are wearing PPE including hard hats, safety goggles, gloves and non-conductive footwear. Position the solar panel at the bottom of the steps, align it perpendicular to the staircase. Ensure that it is stable and will not roll or slide during the lifting operation. Safety precautions. Carefully inspect the solar panel for any sharp edges or protruding parts. Choose a location for the solar panel stand that receives ample sunlight throughout the day and is free from shading obstructions. Solar panels generate electricity by converting sunlight into energy. Placing the solar panel stand in an area with sunlight ensures that the panels receive maximum sun exposure is available, allowing them to produce more electricity. Place the solar panel with stand, align it with the mounting holes on the frame. Position the panel so that it receives maximum sunlight exposure. Safety precautions. During installation, direct contact with the terminals can result in electrical shock or burns, particularly if the panels are exposed to sunlight and generating electricity. Gather the necessary nuts, bolts, washers, and any other hardware required for mounting the solar panel. Insert bolts through the mounting holes on the solar panel starting from the underside of the panel. Place washers on the bolts to distribute the pressure evenly. Once the bolts are inserted through the mounting holes, secure them in place by tightening the fastener onto the exposed threads. Repeat the process for each mounting hole on the solar panel, ensuring that all bolts are securely fastened with nuts. Tighten the nuts evenly to prevent uneven pressure on the panel. Adjust tilt angles and set the tilt angle of the solar panel to optimize sunlight exposure based on your location to receive the maximum sunlight. Now let us see how to measure the open circuit voltage of the solar panel. When you are measuring the voltage of a solar panel, you typically connect the multimeter in parallel. This means you connect the positive terminal of the multimeter to the positive terminal of the solar panel and the negative terminal of the multimeter to the negative terminal of the solar panel. Set the multimeter in DC voltage measurement range with an approximate voltage of 20 volts. Identify the positive terminals and negative terminals in the solar panel. Solar panels come with labels indicating the positive and negative terminals. Look for these labels near the terminals or on the back side of the panel. Place the black probe negative of the multimeter on the negative terminal of the solar panel. Place the red probe positive of the multimeter on the positive terminal of the solar panel. Once the probes are connected, the multimeter ensures the display of the voltage output of the solar panel. Constructing an application circuit for 12 volt DC application. Identify the terminals on the solar panels. Look for any labels or markings near the terminals. They may be labeled as battery as BAT, solar panel as PV, load as load. In a charge controller, the positive and negative terminals are typically labeled or indicated to ensure proper connection of the solar panel, battery, and load. Use black colored wires to connect the negative terminal and red colored wires to connect the positive terminal for easy identification. Strip the wire insulation for half an inch using a wire stripper. Squeeze the handles of the wire stripper to apply pressure to the insulation. The cutting edge of the wire stripper will slice through the insulation without damaging the underlying conductor for both red and black wires. Identify the solar terminals in the charge controller. Connect the positive wire from the solar panel to the positive terminal on the charge controller. Similarly, connect the negative wire from the solar panel to the negative terminal on the charge controller. Once the solar panel is connected to the charge controller, it will continuously monitor the output voltage of the solar panel and display it. Identify the terminals on the charge controller designated for connecting DC loads. These terminals are typically labeled load or DC load. Identify the positive and negative terminals on the 12-volt DC fan. Connect the negative terminal of the fan to the negative terminal of the charge controller. Then connect the positive terminal of the fan through DC breaker to the positive terminal of the charge controller for the allotted terminal. Switch on the breaker and ensure the fan is working. Monitor the solar panel voltage and output voltage to the fan in the charge controller display.
Thus, we have installed the solar power panel 500 watt peak for 12 volt DC application and constructed an application circuit for 12 volt DC application. This concludes this exercise. Thank you for watching. Hello everyone. In today's video, let us learn how to connect storage battery to your power inverter.
At the end of this video, you will be able to connect the battery to the charge controller, connect the power inverter to battery, connect the solar panel to the charge controller. Let us collect all the tools, equipment and materials required to do this practical. Digital multimeter with props, trainees toolkit, crimping tool, power inverter with user manual, output power 300 watts, input 12 volt DC, output 220 volt AC, solar charge controller, type PWM, system voltage 12 to 24 volt, maximum output current 50 amps, battery 12 volt 10 ampere hour, cartridge fuse 1 amps, connecting wires 1.5 square mm and 6 square mm as required. DC circuit breaker, single pole, 12 to 250 volts DC, 6 amps. Lug terminals, ring type, 6 square mm and 1.5 square mm as required. Connecting the battery to the charge controller. Identify the positive and negative terminals of the battery. Set the multimeter in DC voltage measurement range with an approximate voltage of 20 volts and measure its terminal voltage of battery. Ensure the battery voltage is not less than 12 volt. Identify the battery terminals in the solar charge controller. Measure and cut 2 lengths of electrical wire required to connect the battery to the charge controller and the circuit breaker. Remove insulation sleeve at both ends for 12 mm and insert conductor into cable lug terminals as shown. Use crimping tool with correct slot. Crimp the lugs on one end only of both wires. Connect the lug terminal of red wire to the positive terminal of the battery to the positive battery terminal of the charge controller through DC circuit breaker other end of the wire. Connect the lug terminal of black wire to the negative terminal of the battery to the negative battery terminal of the charge controller. Keep enough tightness using the screwdriver. Connecting the power inverter to battery. Safety precautions. The wire connection can only be done after the inverter is fixed in the proper position. Make sure the maximum open circuit voltage and short circuit current of solar arrays do not exceed the stipulated range of the inverter. Identify the battery terminals on the power inverter. The battery terminals on the inverter are typically labeled battery or with symbols representing positive and negative polarity. Use red colored wires to connect the positive terminal and black colored wires to connect the negative terminal for easy identification. Measure and cut 2 lengths of electrical wire. Remove insulation and prepare for connecting the battery to the inverter and the DC circuit breaker. Use crimping tool with correct slot. Crimp the lugs on one end only of both wires. Use one length of black wire to connect the negative terminal of the battery to negative terminal of the inverter. Use one length of red wire to connect the positive terminal of the battery to the DC circuit breaker in series. Now connect the output end of the circuit breaker to the battery terminals input side of the power inverter with the correct polarity, like the positive terminal of the battery to the positive terminal of the power inverter and the negative terminal of the battery to the negative terminal of the power inverter. On the other end of the power inverter output side, you could see the AC output terminals. Connect the load to the AC output terminal of the inverter. Ensure that all connections are secure and tight. If your power inverter has screw terminals, tighten the screws to secure the wires in place. Safety precautions. Choose proper cable for power input and output lines. Identify the polarity of connection ports first, then connect the inverter with solar arrays in proper polarity. While connecting the inverter, make sure no connection among AC-DC and any power resources are disconnected. Connecting the solar panel to the charge controller. Safety precautions. Before making any connections, ensure that the solar panel is not receiving sunlight and that the charge controller is turned off and disconnected from any power sources to prevent electrical hazards. Identify the terminals on both the solar panel and the charge controller. The solar panel typically has 2 wires coming out of it, one positive and one negative. The charge controller also has terminals labeled for solar panel connection, often marked solar or PV with positive and negative signs. Cut and strip the insulation from both ends of wires attached to the solar panel and controller and prepare the conductive wire for connection. Connect the positive red wire from the solar panel to the positive terminal on the charge controller. Likewise, connect the negative wire from the solar panel to the negative terminal on the charge controller. Ensure that the connections are secure and tight to prevent them from coming loose over time. Some charge controllers have screw terminals or other connectors to secure the wires in place. Now, switch on the DC circuit breaker and inverter. Ensure the load connected to the inverter is working and monitor the solar panel and battery voltage on the charge controller display.
In this video, we have discussed and connected the battery to the charge controller, connected the power inverter to the battery, connected the solar panel to the charge controller. This concludes this exercise. Thank you for watching. Hello everyone. In today's video, let us learn how to test the solar panel to the inverter and run the load. This video is split into two parts. Part 1 will cover the testing of the solar panel, connecting it to the battery, charge controller and power inverter, and rest in part 2.
At the end of this video, you will be able to test the solar panel, connect the battery to the charge controller, connect the power inverter to the battery, connect the solar panel to the charge controller. Let us collect the tools, equipments and materials required to do this practical. Trainees toolkit, digital multimeter with props, moving coil ammeter 0 to 15 amps, solar charge controller, type PWM, system voltage 12 to 24 volt, maximum output current 50 amps, power inverter with user manual, output power 300 watts, input 12 volt DC, output 220 volt AC, solar panel 12 volt 100 watt with manual, battery 12 volt 10 ampere hour, AC lamp load 240 volts 100 watt with holders and connecting wires, SPST switch 6 amps 250 volt, DC circuit breaker, single pole, 12 to 250 volts DC, 6 amps. Connecting wires, 1.5 square mm and 6 square mm as required. 6 square millimeter and 1.5 square millimeter as required. Testing the solar panel. Safety precautions. Observe polarities when connecting solar panels and batteries. Photovoltaic panels produce electricity when exposed to light, so it is recommended to cover the front of the solar panel at outdoors to help avoid shocks. This is particularly important for higher voltage panels. Open circuit test. Disconnect the solar panel completely from the battery and charge controller. Position the solar panel towards the sun or any light source. Set the digital multimeter to measure DC voltage at 20 volt range. Identify the positive and negative terminals of the solar panel on the back side, usually indicated with positive and negative signs as shown. Place the positive probe of the multimeter on the positive terminal of the solar panel. Similarly, place the negative probe of the multimeter on the negative terminal of the solar panel. Measure the open circuit voltage of the solar panel. The open circuit voltage is the maximum voltage that a solar panel can produce when there is no load connected to it. Take a note of the voltage reading displayed on the multimeter. This is the open circuit voltage of the solar panel. Compare the measured voltage with the rated or expected open circuit voltage of the solar panel. Short circuit test. Disconnect the solar panel from the charge controller. Position the solar panel towards the sun or light source. Arrange the moving coil ammeter with an appropriate range to measure the current generated by the solar panel. Note: to measure the current, connect the ammeter in series between the solar panel and the charge controller. This means that the current flows through the ammeter on its way from the solar panel to the battery via charge controller. Disconnect the positive terminal of the solar panel from the charge controller. Connect the disconnect positive terminal of the solar panel to the positive terminal of the ammeter. Now connect the negative terminal of the ammeter to the positive terminal of the charge controller. This connection makes to connect the ammeter in series with the solar panel and the charge controller. That is, connecting a positive lead of the ammeter to the positive on the panel and a negative lead of the ammeter to the load via the charge controller. Positive terminal of the solar panel in the charge controller. Once the ammeter is connected in series, it will measure the current flowing through the circuit. The reading displayed on the ammeter represent the short circuit current ISC of the solar panel under the current sunlight conditions. Record the readings that display on the digital multimeter. Note the readings that display display on the ammeter. The measured open circuit voltage and current values are 12 volts and 5 amps respectively. So the power becomes 60 watts when the voltage and current values are multiplied. Connecting the battery to the charge controller. Safety precautions. Ensure that you match the positive terminal of the battery with the positive terminal of the charge controller and the same for the negative terminals. Reversing polarity can damage the equipment. Identify the battery terminals with positive and negative sign in the charge controller. The charge controller typically has labeled terminals for connection. Connect the positive terminal of the battery to the positive terminal of the charge controller. Connect the negative terminal of the battery to the negative terminal of the charge controller. Connecting the power inverter to the battery. Identify the battery terminals on the power inverter with positive and negative signs or red and black terminals for positive and negative respectively. Connect the negative terminal of the battery to negative terminal of the inverter. Connect the positive terminal of the battery to the input of the DC circuit breaker. Connect the output side of the DC circuit breaker to the power inverter with the correct polarities, like the positive and negative terminals of the battery to the positive and negative terminals of the inverter. Connecting the solar panel to the charge controller. Safety precautions. Solar panels generate electricity when exposed to sunlight. The terminals of the solar panels carry this electrical current, and coming into contact with them can result in electric shock. Identify the terminals on the charge controller for connecting the solar panel with positive and negative signs. Connect the positive wire from the solar panel to the positive terminal on the charge controller. Likewise, connect the negative wire from the solar panel to the negative terminal on the charge controller. Tighten the screws securely to prevent any loose connections.
In this video, we have tested the solar panel, connected the battery to the charge controller, connected the power inverter to the battery, connected the solar panel to the charge controller. This concludes part 1. See you in part 2. Hello everyone. In the last video, we have learned testing of the solar panel, connecting it to battery, charge controller and power inverter. In continuation of that, in this we learned how to be connecting the AC load and run the circuit and connecting the DC load and run the circuit.
Connecting the AC load to the power inverter. A power inverter converts the DC power usually from batteries or solar panels into AC power. Identify the AC outlet in the power inverter. Most inverters have standard AC outlets where you can plug in your appliances directly. Set your multimeter to measure AC voltage. Switch on the power inverter. Place the multimeter probes in the AC output socket of the power inverter. Unlike with DC voltage, AC voltage measurement does not have polarity. Therefore, the polarity of the probes does not matter when connecting them to the output socket for AC voltage measurement. But the multimeter must be connected parallel to the AC voltage sockets to measure the output voltage. Once the multimeter probes are securely in place, read the measurement displayed on the multimeter. This will be the AC voltage output of your power inverter. Compare the measured voltage to the expected or rated voltage output of the power inverter. Turn off the power inverter. Choose a 2-pole AC circuit breaker that is appropriate for the power rating of your inverter and the expected current of your AC load. Using appropriate size of wires, connect one AC output wire from the inverter to one terminal of the MCB. Connect the AC output terminals of the power inverter to the input terminals of the AC circuit breaker. Connect the other AC output wire from the inverter to the other terminal of the MCB. Connect the AC load to the output terminals of the circuit breaker. This can be done using standard AC cables terminated with appropriate connectors. Make sure that the load connections are secure and properly insulated. Once the AC output of the inverter is connected to the circuit breaker and the load, switch on the power inverter using the power switch. After the inverter is powered on, switch on the circuit breaker by moving the knob to the on position, usually upwards. Monitor the operation of the inverter, circuit breaker, connected load and ensure the load operates successfully without tripping the circuit breaker. Connecting the DC load to the charge controller. Identify the load terminals in the charge controller. Solar charge controllers typically have terminals labeled for connecting loads with positive and negative signs. Set your multimeter to measure DC voltage, as solar charge controllers typically output DC voltage. Ensure that the solar charge controller is turned on and operational. Touch the metal tips of the probes to the corresponding terminals of the load terminal. The black probe should be on the negative terminal and the red probe should be on the positive terminal. Once the probes are securely in place, read the measurement displayed on the multimeter. Ensure the multimeter reads 12 volts. If the reading fluctuates, wait for it to stabilize before recording the voltage. Ensure that the voltage requirements of your DC load match the output voltage of the solar charge controller. Most charge controllers' output is 12 volts or 24 volts DC. Switch off the charge controller. Connect the other end of the negative wire from the DC load to the negative terminal on the charge controller labeled for the load. Connect one end of the positive wire from the DC load to the positive terminal on the charge controller labeled for the load through the switch. Tighten the screws securely to prevent any loose connections. After ensuring everything is properly connected and secured, you can switch on the DC load and monitor its working.
In this video, we have connected the AC load to the power inverter, connected the DC load to the charge controller. This concludes this exercise.